Single replacement reactions are some of my favorite to be able to predict. There's a very clear-cut set of rules that we can use to actually predict the products of these chemical reactions. Now, just as a reminder, single replacement reactions are those reactions that are between an element and a compound. You can see this in the general form of the chemical reaction. A would represent the element, and BC would represent the ionic compound. What can happen during the course of a single replacement reaction is that the element can actually replace one of the two elements on the inside of the compound. But again, we need a clear-cut system of rules for predicting when this can happen. Here's a good example. We have the reaction of lithium plus calcium chloride. Of course, lithium would be the element and calcium chloride would be our compound. We have some initial rules here for you to follow. Number one, we need to figure out which two elements are going to go head to head and duke it out for the position on the inside of the compound. First of all, metals can only take on other metals, and nonmetals can only take on other nonmetals. It is impossible for these two different classes of elements to take each other on. So again, just like we would classify boxers in a fight, heavyweight versus lightweight, it's almost the same thing. We don't want to kind of cross those two classes. Metals fight metals, nonmetals fight nonmetals, and essentially it's winner takes all. Whatever's left over, the winner of that fight is going to take it over. Let's take a look at a little bit more of a clear-cut example here. So the first thing that I'm going to do when I'm taking a look at my chemical example is classify what element is what kind of element. So lithium, if I look on my periodic table, that's a metal. Calcium, also a metal. So the lithium and the calcium are going to fight each other. What are they fighting for? They're fighting for my non-metal, chlorine, since that's the odd man out. We just need to figure out, is calcium able to hold on to that chlorine, or is lithium going to come in and take it over? So how do we know who's going to be able to win this fight? Well, we're not going into this blind, just kind of like you wouldn't go into a boxing match, not kind of already being able to predict who might have the best chance of winning. We rank our boxers in order of, say, the number of matches that they would win. We do the same thing with our metals and our non-metals in something that we call the activity series. At the top, we would say that these metals are very active, and at the bottom, we would say that these metals are not very active. And very simply, the ones at the top are more likely to win this fight, and the ones at the bottom are less likely to win this fight. We call this ability to win being active. So again, the more active metals would be toward the top, the less active metals would be to the bottom. So in this specific example, I would need to figure out where lithium and calcium are on this fight chart. Here they are, and you can see lithium is ranked higher than calcium. That means that lithium is going to win this fight. Now, if you'll notice, lithium doesn't have the prize. The prize is calcium, the chlorine rather. So the lithium is going to trade places with the calcium to win the prize. That's chlorine. So the first step here, we would switch the metals. Calcium is now going to be by itself, and lithium is going to be able to sit next to the chlorine. Next, we're going to list the charges for the compound and crisscross to make a good chemical formula. Luckily for this one, lithium is +1, chlorine is -1. So after we crisscross, those are just going to cancel out and drop down to, well, what we would see as nothing. The next thing we're going to have to worry about is whether or not our element is subject to the Brinkelhoff rule. Is it a diatomic element? You can see calcium is not part of the name Brinkelhoff, so we don't have to do anything with that element at this time. We should take a moment to balance our equation. We can do that simply by adding 2's in front of the two lithium materials. And then finally, I need to add some state symbols. And just as a reminder about where to find these, For the compound, we would want to use the solubility rules on the back of the periodic table. We're going to limit our choices to either S being insoluble or AQ being soluble. For elements, we would need to use a color-coded periodic table. Calcium is in the metal area, and most of those metals are in fact solids. Let's try on another example for size here. So again, we have calcium and lithium fighting for chlorine, but if you'll notice, in this orientation, we've actually switched their positions. Lithium, again, is at the top, where calcium is a little bit lower. Lithium is still predicted to win this fight. But lithium already has the prize of chlorine. So does anything happen? No. This case, when the metal that is higher up on the list is already on the inside of the compound, we would predict that no reaction would occur. You can actually simplify this just by simply writing NR on the product side. Well, let's take a look at one more example. How about fluorine added with lithium chloride? Again, you're going to want to take a moment and just decide what type of elements that we're dealing with here. In this case, both fluorine and chlorine are both nonmetals. They're going to fight each other. And what are they fighting for? They're fighting for lithium. Who's going to win? We need a fight chart. We need to see how these fighters are ranked. And according to this non-metal activity series, we can see that fluorine is actually more active than chlorine. What that means? Fluorine will win this fight. So fluorine does not yet have the prize. See how it's off by itself? It's going to boot chlorine out, and chlorine is now going to be by itself. So let's switch their places. So chlorine, again, is going to be written by itself, and the fluorine is going to take the chlorine's place in the compound. Now we just need to clean up our equation. Make sure you crisscross the charges of your new compound. Luckily, again, this is a positive one and a negative one, so they will crisscross and reduce. Next, make sure that you Brinkelhoff your element. Now, chlorine is part of Brinkelhoff, so when we write it by itself, we do need to put a little subscript 2 to make it diatomic. Finally, we want to make sure that we balance our chemical equation, and I can do that simply by putting 2 2s in front of our lithium compounds. And we need to make sure that we put in those state symbols. So again, for the compound, use the solubility rules. In this case, it's AQ. For the element, use the color-coded periodic table. And that is predicting products for single replacement reactions. Remember, when you're using the activity series, if the element that's in the compound is already higher on the list, no reaction will occur.